Hello everyone. This is my demo for the project Market Anomaly Detection. Let's first look at the dataset. So this is my dataset. You will find the link for this dataset in my description. There are total 42 columns in this dataset, and it is a time series dataset from the real world market. This column Y represent as a target variable and 0 represent crash at particular day for no crash at particular day in the market, and 1 represent a crash in the market. So after analyzing data, we can easily see that all the crashes happen mostly during black swan events like dot-com bubble and COVID-19 and everything. But other than also there are some prices which is recorded in this data, and we are going to fine tune and build our model by using this data to predict a future crashes of the market based on these features. These are nothing but all the indices which give us idea about how market is working as of now. So to create a model, first, we load and pre-process the data set. Then we build three models: isolation forest, logistic regression, and neural networks for 5 different metrics, because there are lots of features and we can just not build a model on all features. It will give us poor performance. So we are going to use some metrics based on online research, uh, and we will uh, use different features for different metrics and build all three models. So this is my notebook for model creation, where I have imported all the libraries, loaded the data, and this is a pre-processing task where all the you can see all the correlation between all the columns. And then before feeding my all data to model directly, I am here normalizing my data using min-max scaler. And this is a function which builds the model. So as I said that I am using 5 different metrics. So for the first metrics, I am only going to use the 2 columns weeks index and BDIY, and I'll build all three models: isolation forest, then logistic regression, and neural network. So you will see all the performance for all these metrics and all these different models. For example, this is a second metric where I am using these columns to build all three models, and all the models and everything with performance you will find in this Colab notebook. So after model creation, I'm using LLM with a RAG pipeline in this project. So for that, I am creating a vector database of all the stocks data. So for that one, I'm using first of all Pinecone as a vector DB, and I'm pulling out all the stocks data from Yahoo Finance. So here is a code for fetching the data and then convert it into the embedding, and then save that embeddings into the Pinecone vector DB. So I'm using Hugging Face vector embedding. One can use any vector embedding. They have like OpenAI vector embeddings. And once I save all the data to my dataset, it will look something like this. And I have all the stocks data saved over here as vector embeddings. Then let's go through my working application, where first I am taking input from the user. Then we will predict the market crashes by using all the model of all 5 metrics. And then we will also see the overall output of the model, like if a market is crashing or no. Like I use voting of different models and different metrics to come to a conclusion about crash or no crash. Then all this user input and model output is used to generate investment plan for a user using LLM. And then also interface is provided to the user to query a chatbot, which can then convert user query to vector embedding and then fetch all the relevant data from the Pinecone DB using some similarity such as cosine similarity, and then using all the fetch data from the Pinecone user input and model output, our LLM will give an answer to user query. Let's take a quick demo. Okay. So over here, you can see like there are lots of user input. So that's why I also define some default values. So I don't have to change all the inputs for the demo purposes. So there are, you see all the five metrics. The first metric is liquidity and money market indicator, where this three particular column is used to predict market crash or no crash. For the second metrics, currency and commodities goal, these columns are used, or you can see these indices are used to predict a crash or no crash. For equity market indicators, these indexes are used. For economic sentiment and rates, these indexes are used. And for volatility indicators, VIX and VDIY is used. I'm using a default values as of now and click on predict market crashes. So as you can see, my overall prediction is no crash, but you can also see prediction as per all five metrics. This is the prediction from the first matrix, which is this is a prediction from the first matrix, which is uses this as indices to predict crash or no crash. And you can see this particular metric predicted as a no crash, and you will also see all the and you will also see output of all the different models for that particular metrics. For example, as per this metric, it's saying it's going to crash because all three models is predicting as a crash. But as overall, as I'm using voting, overall vote for no crash is more, so overall market prediction is crash. And then here it is AI generated investment strategies for investor. They can also ask a specific question that like which which are the best stocks as per this market situation in CPU market, you can say. Okay, so I got the output. So it's using all the data and also suggesting me some specific stocks that I can invest in as of now based on this market situation. And all of this data is coming from our vector DB Pinecone, where we store all the stocks data from Yahoo Finance. Let me try with some different parameters to see the scenario for crash. So mostly when VIX is more than 30, the market is going to crash. I'll put it as 60, and let me put this one as 2000. Predict market crashes. Okay, as you can see, the overall prediction is crash, and then also it's giving me some specific advice for my market investment strategies. So that's it from my side. Thank you so much for watching.